Taught this many years, and I promise if you are only partially paying attention, you will not be able to do this, and it's going to be hard. But if you pay attention, I'm going to explain it very slowly and make sense of it. Okay, so we're going to be doing properties of exponents today. How many of you remember learning this? Raise your hand. Anybody? Look at your paper. Do you remember something similar? Okay, awesome. So, couple things. So you're going to hear me use some vocabulary, and you have to know what I'm talking about so that you can comprehend what we're doing here. So the first vocabulary word is, if I say base, I'm talking about this big thing here. That's called a base. Anything big. And then an exponent is this small thing up here. That's the exponent. So base is the big thing. If I say the base, that's what you're looking at. If I say the exponent, you're looking up at the little guy. You've got to have those vocab down so you don't get confused when I say the base. The exponent, okay? So if I gave you 2 to the x power, what's the base? What's the exponent? Okay, if I gave you 3 to the second power, what's the base? And what's the exponent? Okay, good, we got it. Now if I said same base, x to the third and x to the fourth, wouldn't we say yes, that's the same base? X and x? Is it the same exponent? No. Okay, just making sure we understand vocabulary. Okay, here's our first rule. This is the first property of exponent, and it's really important. So it's called the zero property. So this is where a lot of students mess up. So listen carefully. Any base raised to the 0 power. So any base that has a 0 exponent, right? So power means exponent. Any base raised to the 0 power, the whole thing simplifies to become a 1. Does everybody understand? If a base is raised to the 0 power, the whole base goes away and the whole thing becomes a 1. So let me show you what it is not. This is what I see students do. They'll say, oh, any base, because you're going to hear me say this, any base to the 0 power is 1. So let me show you what people do. They say, oh, that becomes a 1. So it's a to the 1. That is wrong. The whole base went away and it all became a 1. Do we understand the difference? Okay, so what's x? Base x to the 0 power? 1. Now looking at here, 2 and x are in parentheses. So aren't they both raised to the 0 power? Yes, they are, right? If anything's in parentheses, it's saying all this stuff, this is happening to all this stuff. So what's this going to simplify to be? Guys, any base to the 0 power is a 1. Do we understand the rule? So what's smiley face to the 0 power? What's 2x to the 0? Now careful here. This is where people mess up. Do you see how there's no parentheses on this? That means 2 times x to the 0. The only thing that's raised to the 0 power is base x. Do you see the difference between those two things? The parentheses were saying all this stuff to the 0 power, so it all became 1. This is just x to the 0 power. So only this becomes a 1. So what's 2 times 1? 2. Everybody good? No questions? All right, next rule then. So the negative exponent rule. The rule is, and we only usually, every teacher teaches this differently. This is how I teach it. The last thing we do is look to see if our answer is acceptable. If there's negative exponents in your final answer, you have to fix it. It's not considered simplified. So this is how we fix negative exponents. So when you have a negative exponent, you must flip the base over a fraction, and it will make it a positive exponent. So everybody look right here. This is the rule you would write down. Base A raised to the negative n power. You see how my exponent is negative? That's considered not simplified. So what we would do is we would draw a line down here. We would take the entire base. We would flip it down over the fraction. So that puts it on bottom. Everybody see? Now, because I flipped it, it makes it a positive exponent, but the base is now on bottom of the fraction. Now, we can't just say that there's nothing left on top, because there's a 1 always left on top. So 1 is still up there. So do you see how that fixes it, everybody? Okay, so then this would be a better answer than this, because this has a positive exponent, but it is flipped over a fraction. So let's do this one. We have base x raised to the negative 2 power. This is not an acceptable thing. We can't have negative exponents in our final answer. So we're going to take our base, and we're going to flip it down over a fraction. So that put x on bottom, and now it's going to be positive 2. What's left on top? 1. So we'd write 1 over x to the positive 2. Don't make the tragic mistake of what some students do when they get going fast. They flip it, and then they put a negative again. Well, no, that defeats the purpose of why we flipped it, right, everybody? Okay, so it was positive. So a to the negative 4, not an acceptable answer. So we would take the base, flip it down, and it's going to be a to the 4th. 1 over a to the 4th is equal to that, but this is the more simplified answer. Okay, that rule works both ways. So for example, I'm going to scroll up so those of you in back can see this. So for example, looking at 3 divided by x to the negative 2. Do you see how we have a negative exponent on the bottom? We could fix this by taking the base, flipping it over the fraction. So that puts it up here, right? And now it's positive 2. So on top we have 3 times x squared divided by 1, right? Now anything divided by 1 is just itself, so our final answer would be 3x squared. We wouldn't need to write the 1 for this one because dividing by 1 is the same thing as just 3x squared. Okay, so 1 over b to the negative 3, we would take our base and flip it over a fraction, putting b to the positive 3 on top. So we have 1 times b to the 3rd on top, which is just 1 times b to the 3rd, and then over 1. Now, do we need to write that 1? No, because isn't 1 times anything just itself? And then anything divided by 1 is still itself. So do you see how we can just write b to the 3rd, everybody? Okay. That would be our final answer. Okay, let's see if I put, okay. Now let me show you a tragic mistake. I put a caution sign because you can't do this. Everybody watch. Very big caution, 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 caution. Okay, looking at this example, 2 times x to the negative 2. 2 is not connected to x to the negative 2, even though it looks like it is. It is not connected. So is it connected? No. 2 is actually raised to the positive 1 power. Isn't 2 to the 1st? Okay, so we only flip negative exponents. Is that a negative exponent? No. So this is a negative exponent, so that needs to be fixed. We take that base, we flip it over a fraction, putting x on bottom, and it's positive 2 now. This 2 was not connected. If you put the 2 on bottom with x squared, it would be marked wrong. You all understand? So it helps to write 2 to the 1st so that you don't accidentally flip that. So our final answer would be 2 over x squared. Does everybody see how I only flipped the negative exponent part? Yes or no? Yes. Okay, what about this one? Is 3 connected? No, it's 3 times x to the negative 4. So we only take this piece and flip it. Right? Are you understanding back here in the middle? Okay? So we have a 3 on top and on bottom x to the 4th, right? We flipped it. It became positive. So do you see how I wrote it like that? Okay, so looking at this one, is 3 connected to x to the negative 2? Don't zone out or you're going to start getting these wrong. Is 3 connected to x to the negative 2? No, it's just multiplication. So isn't this the only one that needs to be fixed? So that comes up x squared. So now on top we have 1 times x squared. On bottom we have a 3, right? Now do we need to write the 1 times x squared? Isn't 1 times anything just itself? So we don't even need to write that. Everybody good? Okay. All right, next property. Okay, wait till after the lesson. I don't know where the person is yet. I'm wearing Wednesday. Don't go yet. Wait till after my lesson. Okay, so multiplication property. This is one of the biggest ones, which my students always end up being pretty good at properties of exponents because I like to think that I'm a pretty good teacher. So, when you multiply the same base, it has to be the exact same base. When you multiply the exact same base, then you add your exponents. So we're multiplying base A and base A, so they're the same base. When you multiply the same base, you add your exponents. You see how I put this together So what we're essentially doing, guys, is we're taking, instead of having 2 A's, we want 1 A. Does that make sense, everybody? So what we're essentially doing is taking those 2 A's, using properties of exponents to make it all simplified to only have 1 A. When you multiply the same base, you add your exponents. So that's where my song begins, my properties of exponent song. So the first rule is, I'm just going to sing the first part, which is literally, when you multiply, you add. So that is only for same base, and that is only exponents. So that rule only works when you multiply, you add your exponents, and that's only if you have the same base. So let's look at this very simple example here, everybody. X squared times x to the third. Aren't we multiplying the same base? So we should be adding our exponents. So we're pulling this into 1 base x. Then we're going to be doing 2 plus 3, which is x to the fifth. Now let me explain why that works. Watch. X squared is x times x, right? X to the third is x times x times x. How many x's do we have? 1, 2, 3, 4, 5. So that's why the property of exponent rule works here. Does everybody understand? Now that rule works always, no matter what, if they're negative exponents, if they're zeros, if they're anything. When you multiply the same base, you simply add your exponent. Okay, so let's look at this. Same base, same base, same base, yeah? So we should be adding our exponents. Let me show you a tragic mistake students do. They say this is exponent 0. Not true. Isn't this 1? Always write in, that's the first thing I want you to do, is if you see no exponent there, put a 1. Okay, when you multiply the same base, you add your exponents. Let's do that then. What's base x, and then we have negative 1 plus 3 plus 1. So negative 1 plus 3 plus 1 is 3. So that's simplified to be x to the third. You see how we're building up here? When you multiply, you add, but only exponents. Okay, looking at this, x squared times a squared. Do we have the same base? No, even though it's the same exponent, the rule is when you multiply the same base, you add your exponent. So that you couldn't do. That's simply x squared, a squared. You couldn't put them together. That's it, you couldn't put them together. Okay, here's our first more advanced example. So refocus in. We have 2x cubed times 3x to the negative 2. Now let me show you what students tend to think. They say, oh, 2 is connected to x cubed. 3 is connected to x to the negative 2, which is not true. This is literally just 2 times x to the third times 3 times x to the negative 2. You see how it's just all multiplication? So I want to see your work. What you're going to do is reorder this. Put everything that's like by each other. So numbers, we're going to put by each other, okay? So reordering this. 2 times 3. You see how I just put it in a different order? And then we have an x cubed, so times x cubed. And then we have times x to the negative 2. So I just put it in a more pretty order. Same thing, different order. Now the rule is not, let me show you what I see students do. They say, when you multiply, you add. Well, no, numbers, guys, we're multiplying numbers. Like multiplication didn't all of a sudden magically become addition. So 2 times 3 is 6. Do not add those, right? 2 times 3 is 6. That rule does not work for multiplication. It does, however, work when you multiply the same base, you add your exponents. So that would be 3 plus negative 2, which is 1. Now we don't have to write that 1, so 6x would be our final answer. Okay, another more advanced example here. We're building, and then we'll start doing some off the worksheet. Negative 4 times a squared times negative 3 times a times 2 times a to the negative 2. First thing you should be doing is saying that a has a what kind of exponent? 1, right? Okay, next thing you should be saying, 4, it looks like it's connected to a squared, but I know it's not. This is just negative 4 times a squared times negative 3 times a times 2 times a to the negative 2. So let's reorder this in a different order. We have a negative 4 times a negative 3, right? I'm just reordering it. Do we all know what I'm doing? Times 2, because it is not connected. Now we have our a squared. Why am I doing this? To put like things by each other. A squared times a to the first I'm crossing them out so I don't miss anything. Times a to the negative 2. Are we all seeing how I just reordered it? Okay, and now you're going to do the simplifying. Multiplication is always multiplication. Negative 4 times negative 3 is 12, positive 12. 12 times 2 is 24. I just simplified that. Now look, same base, we're multiplying the same base, so we add our exponents. 2 plus 1 minus 2 is 8, no, 1, good, perfect. So we could just write 24a. Everybody see how that worked? It was pretty easy, right? As long as we reorder it. And as long as we don't get tricked by saying, oh, that was connected. 2 was connected to a squared. It's not. Okay. Number 4 on the worksheet. Here we go. Let's do number 4. So we have 3ab cubed times 4a to the negative 3b to the negative 2. This looks like it's trying to trick you. It's trying to make you think all that stuff's connected. But it's not. It's just multiplication, right, everybody? Multiplication is not connected, so let's reorder it. Let's put like things by like things. We have 3 times 4. Let's put our a's by each other. So that's a to the what power? Right here? A to the first, good. Times a to the negative 3, right? Times b to the third. Times b to the negative 2. And now we're to the spot where we can simplify. Remember, multiplication is always multiplication for numbers. So doesn't that piece become a 12? Cross them out, you've simplified. When you multiply the same base, you add your exponents. So we have a to the negative 2. Let's continue onward. Multiply the same base, you add your exponents. So we have base b to the 1. Now that is my final answer. Is it an acceptable final answer? Not quite, right? We can never leave our final answers with negative exponents, right? So we have one last step. Is 12 a negative exponent? 12 to the first. So we're going to draw our line. We're going to take a to the negative 2, take that base, flip it over a fraction. So it's now on bottom, and it's now positive 2. So I'm going to make you rewrite this so that I have pretty answers. 12 is on top, b is on top. I don't need to put b to the first because b to the first is just b. And on bottom we have a to the positive 2. This would be the final acceptable answer. Can you guys do those ones? Okay. What I want you to do is, do we need to do this one? One more, and then I'll let you go for it?
Yeah.
Okay, last one, and then I'll let you do 1 through 10. Here we go. Yeah, let's do this on a whiteboard, and then you hold it up, and then we can go through it together. So see if you can do it. Okay, so let's go do this slow. Pay attention to the way I teach, and then you can do it that way, and then you can actually do it. Don't go back to the old ways of doing things. So what's our first step, guys? We reorder, correct? So I saw most of you doing that. Here we go. We write our negative 2 times negative 3. Do we have questions? Oh. Okay, now we have x to the 0, so times x to the 0. Let's put our x by that. What comes next? Y's, sure. Y to the negative 3. Y to the 1. Now all you have to do is simplify in sections. I just am so confused at what was so hard. Okay, let's do this. Tell me what that is. 6. Okay, so you can actually do it. When you multiply the same base, you add. 0 plus negative 2 is negative 2, right? That's one way of doing it. Or those of you that went like this is also correct. X to the 0 power is 1. So let's just pretend x isn't there because that became a 1. So don't we end up with the same thing? That's how you did it, which was right. Perfectly right. Okay, next one. When you multiply the same base, you add. Y to the -2. You'd say, that's my final answer. Is it an acceptable final answer? No. So we have negative exponents in our final answer. No. Now, is this 6 to a negative exponent? No. 6 to the positive 1. Right? Oh, looky look. That has a negative exponent. We need to flip the base over a fraction, right? Uh-oh, that does too. So that's coming down too. So now those are gone on top. Left on top was 6 to the first power, which is 6. On bottom, x squared, y squared. You guys, pay attention. Do the same steps. It's no different. You got it now. I'm a little bit concerned, but maybe we're good. After seeing that one more time, okay? Maybe getting our butts chewed a little. Okay, do 1 through 10 on your worksheet, and then check them off with me. Maybe do 2 of them, check them. Ready, go. Just remember that if you don't get done what I think you should get done in class, you do not get the participation points. So, next property. You'll want to go back to your notes. So if you're not done, we'll look back up here because you will start to get them wrong again if we don't pay attention. So next property is the quotient property. What it says is when you divide, so we just learned when you multiply the same base, you put it in the same base by adding, right? When you multiply, you add, right? Well, this is when you divide the same base, you subtract. Now, here's the one rule that you've got to follow. We always subtract the top from the bottom. So do you see how I have the same base and we're dividing? We're going to put this into one base by putting the base on top of the fraction. So I'm going to put it on top of the fraction. And I'm going to take the top exponent and subtract it from, no matter what, whatever the bottom exponent is. So then you have one base, and now you have your exponents combined. So the song goes, when you multiply, you add. When you divide, then you subtract. You always have to subtract the top from bottom. Everybody good? And that base always goes on top to start out with. And then if we need to flip it because we have a negative exponent, we can. So everybody look up here. A to the 5th divided by a to the 3rd. Are we dividing the same base? Yes. So we subtract our exponents, the top from the bottom. So you always put the base on top. So look, A, and then we're going to take our 5 minus 3, which is 2. So that's on top, we have a to the 2nd power. So now because we have a to the 2nd power divided by a 1 technically, we just could write a to the 2nd. Does that make sense, everybody? That's our answer. So look, don't let negative exponents throw you off. We're dividing the same base, so we subtract our exponents. You always put the a on top, the base on top. You'll take that top one, and you'll put a subtraction sign, and now look at the bottom, because this is where people mess up. So now we're going to subtract 3. Now careful here. So on top, I have base a, and then negative 2 minus 3. Don't just say a 1, because there's a 2 and a 3 there. It's negative 5, right? Now, is my final answer an acceptable final answer? No. So we would do our last step, which is take the base, flip it over the fraction, and now we have a 1 left on top, right? And a to the positive 5 on bottom. So this would be our acceptable final answer. It's not hard, yeah. If you think of it this way, other teachers teach it differently, always easy. So let's do number 13 on your worksheet. Do not start doing weird things with numbers. Dividing numbers is dividing numbers, guys. You don't subtract those. That's what I see people do. Does that make sense? 2 over 2 is not when you divide, you subtract. Those are just numbers you got to simplify. So doesn't 2 divide by 2? Don't they both divide by 2? You're going to hear me say it like that. So this divides by 2 and becomes a 1, right? This divides by 2 and becomes a 1. Okay, now let's move on to our next base. On top, now look, on bottom we have x to the negative 4. Are there any x's on top that we need to subtract it with? No, so let's move on to y's. We always write in our exponent 1 if there's not an exponent. So everybody write that in. So now we would say to ourselves, when you divide the same base, you subtract your exponents, and you always subtract the top from the bottom, right? So that's 1 minus the bottom, 3. Now I'm going to cross that out. Does everybody see what I did there? Okay, let's show our work here. So we have a 1 on top times, we have that 1 on top, and then we have y to the 1 minus 3. -2, write it in, draw your line. What do we have on bottom? A 1 times an x to the -4, right? And that's it, right? So you say, that's my final answer. But is my final answer acceptable? No, we have some negative exponents that we need to fix. So that base needs to be flipped over the exponent, and then doesn't this need to be flipped? So we have a 1 on top times x to the +4, because we just flipped and made that a positive exponent. Now on bottom, we have a 1 times, we just flipped that to make it a positive exponent. Now, is it necessary to write the 1s? No. So our final answer is just x to the 4th divided by y squared. And we do not need to we can't put these two together because they're not the same base. I wouldn't mark it wrong, but you wouldn't see the ones there if it was a multiple choice test. Good question. Okay, let's do this one. So I don't want to take away your practice. So look up here at this one. You don't have to take notes if you just watch. First of all, we're going to go in sections. Simplify it in sections. 6/3. Don't they both divide by 3? So this 6 divided by 3 is 2. We got to put the 2 in the correct spot. 3 divides by 3 and becomes a 1. Okay. When you divide the same base, you subtract your exponents, right? Always the top from the bottom. So we're going to start up here. -2 minus, now what's the bottom? -1. You see how where most people mess up? They forget to do 2 negatives because I said -2 minus. Now look at the bottom, -1. Now cross that out. Okay? When you divide, you subtract. So the top from the bottom. So 2 minus 1. And now I cross that out. Let's rewrite what we have. We have a 2 on top. We have x to the -2. Minusing a negative is -2 plus 1, right? If you're subtracting a negative, you would just make it positive. Does that make sense? So -2 plus 1 is -1. Now y to the 2 minus 1 is 1. And then left on bottom was just a 1, correct? Okay, perfect. So then is that answer a final acceptable answer? No. Wouldn't we just flip that? X to the +1, right? So I'd write it pretty. We had a 2 on top. We have y to the first. I'm just going to write y. And then on bottom we had a x. So you just do it in sections. X times 1, technically. But that's just right. That's my final answer. Okay, try that one on your whiteboard. How about? Simplify in sections. So focus on 3 and 6 and simplify it correctly. Make sure you put the 1s where they need to be, the 2s where they need to be. Then when you divide, you subtract. You always subtract the top from the bottom. I want to see if you can do it. Through it. So we simplify it in sections, not making it harder. The rules don't change. It's always the same thing. 3 and 6, we got to simplify this correctly. They both divide by 3. 3 divides by 3 and becomes a 1. 6 divides by 3 and becomes a 2. So 2 has to be on bottom, else you get it wrong. Does everybody agree? When you divide the same base, you subtract your exponents, the top from the bottom. So that's 2 minus 3, right? And then I cross that out. So now it's y. When you divide, then you subtract. So -4 minus 5. So then I cross that out. Let's write what we have left on top. We have our 1 times x to the 2 minus 3. -1, right? -4 minus 5 is -9. And on the bottom we have a 2. Is that an acceptable final answer? No, we can't have negative exponents. So those of you that are trying to do this differently than this process, you shouldn't be. We need to flip that. So will that be x to the +1? Looks like we need to flip that. Y to the 9th. So left on top was a 1. If you didn't write that 1, you'd get it wrong. And on bottom we have a 2, an x to the 1st, which I'm just going to write x, and a y to the 9th. Those of you that made an error, do you see where you made your error? Hey, yeah. Three, oh, good question. 3 over 6, they both divide by 3. So 3 divides by 3 and becomes a 1. 6 divides by 3 and becomes a 2. That way, if you think of it like that, it makes sure to put the 2 in the correct place and then, you know what I mean, the 1. Okay, what I want you to do is everybody go to 11 through 20 and start practicing some of those and checking them off with me so that I can help you if you need help. Do not stray away from the way I was doing it. All you have to do is simplify it in sections when you divide and you subtract. Don't start doing your own thing with them. Because I teach it this way because this is the most way to not get it wrong. Like the most easiest way to not get it wrong.